suppose we have a set of 3 sentences for each class. We have the class TV that actually contains only sentences about TV, and we have the class radio that contains sentences about radio. For example, TV programs are not interesting, TV is annoying, is in the class TV. You could think about, just a similar example where you have spam and non-spam. And the radio it's interesting to listen to the radio. Also, we have a set of 3 sentences for radio and a set of 3 sentences for TV. Okay? So I'm going to build the vocabulary. Only the pertinent words will go into the set. So the vocabulary V will be equal to TV, program, interesting, kids, radio, wave, and listen, and finally rare. Okay? Those are the most important words in this full corpus of text. So we're going to use the first algorithm to calculate the different probability of each class, but also the probability of each word in the classes. This table summarizes the probability of the priors and also the probability of each word in the corpus. So probability of the class TV is 3/6. We have 3 sentences over the 6 sentences that are about the class TV. And likewise, we have probability of C radio is 0.5. NTV is 9. This represents the total number of words positions in all training examples that are actually in TV. So if we go back to the example we have here, so this is the vocabulary, and we have among the vocabulary the word TV, 1, programs 2, interesting 3, 4, 5, 6, 7, 8, and 9. So we have 9 occurrences or 9 positions in the full corpus for TV that actually have that are words from the vocabulary. And same thing for radio. We have 11 words that if you count them, you will find 11 words. Okay, so we have this priors. We have also this number of TV and number of radio that we use actually to calculate the M estimate. So we're going to have all the words in the vocabulary, TV, program, interesting. So these are the 8 words. And we also have the class TV and the class radio. All right, so NTV is unchanged, and radio is here, it's 11. We're going to calculate the number of the word W occurring in the text. So for example, TV occurs 4 times, programs occurs once in the class TV, but TV occurs 0 times in the class radio, in the text of class radio, and program occurs once in the programs of class radio. And we expect that radio will appear more frequently in actually the class radio than the class TV. All right, so I'm going to calculate, this is the M estimate. We're going to apply the formula. That's going to be NW plus 1 divided by N TV plus the size of the vocabulary. All right, so we have these values here. And given this table now, we can predict any kind of new sentence. For example, if we have the sentence, let's say, I saw the radio of my lungs on TV. All right, so the words that are from the vocabulary are radio and TV. That's the only words. We're going to calculate the probability that the class of this sentence, this is the new doc, let's call it, this is new, right? So we're going to estimate the probability of the class for both the class Bain TV and the class Bain radio, and we are going to calculate basically based on the formula in this slide here. We're going to calculate the argmax over these classes. So we need to provide 2 terms. One is the probability of estimate the probability of CTV times the probability of the word radio given the class CTV times the probability of the word TV given the class CTV. Okay, we'll do also the same thing for radio. So the prior radio times the probability of radio given the class, so that's the class given the class radio times the probability of TV given the class radio. So we calculate these 2 terms. With this formulation, with the M estimate, we are guaranteed that none of them will be 0. So we're going to get a number here, we get a number here, and you compare both of them, and the class will be the class of the number that actually is maximum among these two terms.